Welcome to Soil Science and Management, Chapter 11. Today we're going to talk about the importance of soil. The objectives of this chapter are going to be to describe and understand pH, how this affects development and plant growth. We're going to talk about lime and acidifying soil. We're going to perform some lime calculations. We're going to describe what a saline or acidic soil is. And we're going to describe methods to treat and manage saline and sodic soils. So soil pH is basically it's the acidity or alkalinity of a soil, and this soil pH affects plant growth as well as plant nutrients. It is measured on the standard pH scale from 0 to 14, 0 being most acidic, 14 being most alkaline, and neutral being in the middle at directly at 7. When we talk about pH, the pH is basically a logarithmic value of the hydrogen ion concentration within a material, and this is the P stands for your negative log. Your H stands for your hydrogen ion concentration, and when you think about pH, for every number you move, it is considered approximately 10 times stronger. So from 6 to 7, 6 is 10 times stronger as an acid than 7. 5 is 10 times stronger than 6, and if we did the calculation, a 5 is 100 times stronger than a 7. So it perpetuates itself down to 0, and then is exactly the same going towards the 14 number. Most acidic soils that we think about have a pH of approximately 3.5, and then the most basic soils are about 10.5. This soil pH is basically the result of different soil minerals, different ions that are within the soil, different cations that are being exchanged within the soil. When you are thinking about high pH, this is caused by calcium, magnesium, and sodium forming hydroxide ions. So hydroxide is the OH. These are the opposite of the hydrogen ion within a acid. Lower pH is caused by percolation of water. And these are mildly acidic waters. Typically here in California, we have a very alkaline soil. It's anywhere between 7 and 8.5. This is very high in alkalinity, and this is due to the water quality here, as well as limestone activity within California. So back east on the East Coast, they have more acidic soils, and that's due to a different water quality, different parent material. So here we don't really deal with the acidifying soils. So what are the causes of acidity? These are young soils that haven't been exposed to a lot of weathering or leaching, and the reason we don't have these acidic soils in California is because we don't have a lot of rain, where back east they get tons of rain all the time, so that is constantly leaching out these alkaline minerals and leaving the acidic minerals behind. Also, nitrification can be a huge cause of acidity, and the decaying of organic material is a nitrification process, so it is basically causing nitric acid to build up within the soil, and this will cause acidity to be more prevalent. So pH affects plants based mostly on nutrient availability. It affects the ability for the nutrients to move within the soil. So if, for example, iron is one of the most common ones, when the pH gets above 7.5 or so, iron becomes unavailable and it does not move within the soil, and plants are not able to access those nutrients. Also, you can open up your plant for toxicity of certain nutrients, and actually these nutrients could be beneficial nutrients, but the pH allows for the minerals or elements to be in such high concentrations that it can be toxic to the soil. And it will also affect soil organisms, and these soil organisms are very important for the root interface microbes, as well as decay bacteria or nitrification bacteria. There's other bacteria that break down other materials and work to fix the soil. I'm not going to talk too much about this, but if we have an acidic soil, you do something called liming, and this is adding lime to a soil. And the reason I'm not going to talk about this too long is because in California, we don't ever really have to do this because we don't have these acidic soils. So if you do have an acid soil, then you're going to use lime typically to balance out that acidity. So here are the various materials that can be used to lime your soil, and this was one of the things I learned about. I remember learning about in my turfgrass science class was how much of each one of these can fix different pH levels, and so each one of these has basically a different potency for correcting acidity within the soil, and you have to make sure you know how much to put on so you don't go past the point where you'd like it to be. So say you have a 4 pH soil and you want to bring it to a 7, you know you have to move 3 markers, and each one of these products have different abilities to move those markers. So understanding the calculations is pretty critical. So how does it work? Basically, lime neutralizes the soil using 2 different things. It will use anion base, and it will neutralize the hydrogen ions within the soil solution, and it will convert them into part of the water molecules, and these water molecules will then be moved through the soil. Also, calcium can replace the hydrogen ions in the cation exchange sites, and these calciums are allowing the hydrogen ions to be leached through the soil again. So again, we talked about this, and this buffering capacity is the ability of the soil to take the lime, and you have to add certain limes have to require more product to get the same result, and that is considered the buffering capacity of the soil. Here's your lime calculations. Again, I don't really want to get too deep into this, but understand it. It's something important. This total neutralizing power, or the calcium carbonate equivalent, these are 2 different equation formulas that are used to determine how much of this lime you need to basically have a healthy soil. The lime fineness is going to be similar to like a soil fertilizer. The smaller the grind, the faster it works, but also the slower or the least amount of time that it works. Coarser grinds last longer but don't work as fast. Pretty self-explanatory. So effective neutralizing power, these are the calculations and how to effectively utilize a lime product within the soil. So lime application, these are best results are obtained from liming when there is close contact between the grains and the lime. And lime should be spread evenly over the field and then mixed into the soil. So you're going to want to till that lime in if possible, allowing it to incorporate within the soil particles. So we'll talk a little bit more about this, and this is more up our alley. It's if you have a super acidic soil, you want to use sulfur. That is something that will create sulfuric acid once it's in the soil, and this can bring your soil down from your 8.5 down to into your 7, your happy region. And this is what we do here in California. So soil salinity, this refers to the total dissolved solids within the soil, and this is something that is different based on different parts of the country. One of the ways to combat soil salinity is to use percolation to your advantage, or leaching. This is the over-application of water into a soil that has accumulated these TDS markers, and you are pushing those salts down past the root zone of the plant and into other soils or other areas where the salts do not affect the root zone and plant growth. So some of the effects that soil salts can have is osmotic effects, and that is basically the operation of osmosis, and that is how plants utilize water and pick up the nutrients in the water. Salts can cause a lot of stress on roots, and roots do not like to grow within the salt, and actually can become damaged and not allowed to uptake water anymore if the roots get to a certain stress level. Salts can capture ion sites and can be to the detriment of nutrients, because they say if you have an abundance of sodium in the soil, that will kick off other potential nutrients that you'd much rather have in the soil. Salts are an inhibition to microorganisms. They can actually kill them, kind of like when we pour salt in our wounds, we don't like it. Well, salt doesn't like to be poured, our microorganisms don't like salt to be poured on them, so we have to be really careful not to accumulate these salts within the soil, and again, if we have that problem, we have to percolate and wash that salt through out of the root zone of the plant. And then salts can also affect can include a very high pH because of the different minerals that contribute to your total dissolved solids. Saline soils include high levels of soluble salts. These are measured by putting electrical current through. That's going to be your electrical conductivity report, or EC. And the more of these salts that are within the soil, the greater your EC will be. And this is how you can determine how many total dissolved solids you have within your soil. So to be considered a saline soil, you have an EC of 4. Sorry, it's an EC of 4 millimoles and that is basically converted into TDS, and then you determine how much of this salt is within your soil. Sodic soils are the amount of sodium that are found within your soil, and these are basically your when you accumulate too much sodium within the soil, it can have a different effect on plants than just a simple saline soil. And this basically compares the concentration of sodium versus the concentration of calcium and magnesium to determine if it is considered a sodic soil or a saline soil. So these saline sodic soils, they contain both high levels of soluble salts and sodium. Again, the EC is greater than 4. The SAR is greater than 13. And your pH is less than 8.5. So what do you do to fix these salted soils? And it comes up to a few things, and you first want to make sure that it's practical to do this work. Is it financially viable? Is there enough good drainage to give the salt water a place to go? So if you have a very short root system or you are close to bedrock, then you could have a problem in removing the salts from the soil. And then making sure you have good drainage, and if not, then you need to install proper drainage to allow the salts and the salted water to go somewhere. Basically, when you're reclaiming these salted soils, you're going to flush or leach these salts through the soil. So you are going to use a higher quality irrigation water. This is pretty prevalent in the reclaimed water industry. If you are watering with reclaimed water, they tend to be higher in TDS or sodiums than your potable water, and these solids can be built up within the soil. And to do that is, once a year or every 6 months or so, you want to flush that water through with something that's a really high quality water. So maybe a portable water system can be also dual plumbed, and you can flush the salts out of the soil using this higher quality water. So you got to calculate how much leach salt you believe you have, and you want to make sure you irrigate enough to push that leach salt through. You have to be very careful when you're going to do this, because you don't want to waste money by, say, fertilizing before you start to leach, because then you're going to be pushing your fertilizer through. So this is usually a managed operation. It's timed. It's done with precision. It's done at a certain time. This is actually a pretty complicated thing. So there are issues with salted water, and typically here, not necessarily in California, we don't really have the water that we pull back out. So we let it push through to wherever it goes, eventually joining the aquifer, and then it is diluted within the aquifer so that the salts do not affect the quality of the water. So managing your salts within potted plants, again, not super important. You can again leach your potted plants. I would recommend doing it every 3 to 4 months, and that's watering until the water comes out the bottom, and then continue to water for several minutes and allow those salts to be pushed through the soil and into the ground. So we talked about soil pH and how that's affecting different parts of your soil. We talked about what happens if your soil is too acidic, too alkaline, too saline, too sodic. We discussed liming and why that's done. we discussed a bit of sulfur and why that's done, and we talked quite a bit about leaching and how we can utilize that to reduce the amount of salts that we have within our soil. So I thank you for joining me, and I hope that this was interesting.